Hello class, welcome to today's lesson. We will finish subtopic 2.10, solution to equations analytically and graphically, or by analytical means and graphical means. We have already covered the analytical part, and basically in that part I just gave you some equations. Don't think that series of 20 equations is in any way exhaustive. There are hundreds and hundreds of different types of equations, and I just gave you a very small set of the equations that can be solved analytically. And basically what I did is introducing you to a new technique, right? The one about substitution. And with that one, you can solve equations like exponential equations, like you were solving a quadratic equation. Okay, so that's basically what we did in this part. Now we're gonna go to the graphical part and then numerical part. So for the most part of the equations, guys, that you will encounter, those equations, I don't know, let's come up with something like 3x squared plus e to the x plus 1 equals 1 over x. Something like this cannot be solved, well, in principle, cannot be solved by an analytical approach. The most general equations cannot be solved by analytical approaches, okay? You cannot really devise a technique with which just by pencil and paper you can solve equations like this or even more complicated ones. I don't know, let's say e to the x over x squared, the square root of all of this plus e to the 2x equals, I don't know, the square root of e to the x. Something like this is very complex, and to devise a technique, an analytical technique to solve any general equation is very hard to do, extremely hard to do. So basically what scientists do and mathematicians do is they go for graphical or numerical techniques. And basically what I mean by numerical is basically resort to a calculator like the TI. Okay, basically what you're gonna do is input this type of equation with one variable. Your variable is x, into the same thing that we already studied, right? Something like this in the calculator. You just input your equation here and you say solve for x. That's what the comma and the x stand for. Solve for x, this equation, please solve it for x. That's what all of this notation means. And the calculator will give you the roots or the solutions or the zeros of the equation. Fine. So that's what we mean by numerical. Basically, use a calculator. It's that simple. Okay. The other technique that we're gonna look at is the graphical technique. Let me erase all of this. So we have a numerical technique, which is basically using a calculator. And the other technique, which is the graphical technique, consists of the following. Suppose that you have a graphing calculator, like so, like Desmos, right? Like the one we use quite often, like this. Any graphical calculator in which you can plot any equation, okay? I don't know, y equals 2x minus 1, or any function, f of x equals x to the square minus 2x plus 6 plus 5, I'm sorry, anything. And the calculator gives you the graph of such equation into variables or such function, you see? So suppose you have this, and the question is, can this help you solve equations in one variable? Can this graphing calculator, whether Desmos or the TI is also a graphing calculator, you will see in a moment how to use it. So can this sort of software help you in the solution of equations with one variable? And the answer is yes. But first, I'm gonna remind you about the zeros of a function, the zeros or the roots. Okay, let's do that very quickly. Suppose I give you the function f of x equals 3x minus 6. Let's keep it simple. You have this function, f of x equals 3x minus 6. And the roots are those values of x, so that when you input that value in here, in the expression for the function, the value of the function goes to 0. So for this particular function, my zeros or my roots, which can be more than one, in this case is just x equals 2. Why? Because when I substitute this value in this expression, I'm going to get 3 times 2, which is 6, minus 6, which is 0. Therefore, f of x is 0 when x equals 2. That's why this number is called the 0 or the root of the equation. I'm going to write that again because this is the root or the 0 of this function, because for x equals 2, we have that f of x equals 0. Okay, so that was just a little reminder. Now the next thing I want you to notice is the following. This is the first thing. The second thing is this: any equation in one variable, let's write whatever equation, 3x squared minus e to the x plus 1 equals 2x plus 4. Okay, any random equation. Any equation like this can be written in the following way. I can bring all my terms, all of them, to the left side or to the right side. To one side, that's what I mean. So let's move all of them to the left side. Then I'm going to simplify. So 3x squared minus 2x is going to be x squared minus e to the x. And then we have, I forgot the equals 0 here. Then we have minus 3. So any equation in one variable or any other variables can be written like this. Some expression equals 0. You must agree with that, right? Okay, now what's up with that? How can this help me solve my equation? Or why am I talking about this? Because once you do this, you can do the following. You can create, with this expression on the left side, you can create a function. You can say, okay, I'm gonna make a function, I'm gonna create a function f of x, which is going to be equal to all of this expression. Can we do that? Sure, why not? You see? So with this side of the equation, with this expression, I have created the function f of x equals all of this. Okay, fine. Now what? Okay, notice that if we get the zeros of this function, the zeros, I'm going to continue over here. Well, I'm going to erase this line. Minus 3. Erase this line. I'm going to continue here. I'm going to write down the same function again. Okay, now we have this function, and I said, let's suppose we get the zeros of this function. Okay, any value of x such that when I input such value of x, all of this number will be 0. And let's suppose such value of x is equal to r. Okay, I don't know what r is for this particular case because it's kind of complex, but let's suppose we have already found at least one 0 for this function, and that 0 is r, the number r. That means the following: for x equals r, f of x equals 0, which means the following. You see? And basically, guys, what this means, if you pay attention, what this means is that R, the number R, is a solution to all of this equation, right? Look at that. You see, because it's the same. Of course, it's backwards, but okay. Let me put it in that in this precise order, so that you can see perfectly well what I mean. We have R squared minus e to the r minus 3 equals 0. And if you notice, this is the same as this. And what I mean is that r is a solution to this equation. Okay, the roots or the zeros of this function are basically the solutions to this equation. Okay, by having this equation and creating a function out of its one of the expressions, in this case the left side, then by getting the roots of this equation, or the zeros, those roots and those zeros will be the solutions to this equation. Okay, that's basically the whole point. Now let's actually see what the zeros are for this equation. We have x squared. Well, we have this function f of x equals x squared minus e to the x minus 3. Let's memorize that thing, please, and let's go to Desmos. And let's find the zeros graphically. F of x equals x squared minus e to the x plus, was it plus 1? I can't remember. Minus 3. Okay, if we can see, the function looks kind of weird, but the function crosses the x-axis at this point. So this is the root or the zero for this particular function. The zero is minus 1.78. This is the root, guys. This is the zero, minus 1.78. Therefore, this particular number is the solution to my equation, which is this one. Okay, 1.7 minus 1.78. If I input in this equation minus 1.78, like so, minus 1.78 to the square minus e to the minus 1.78 minus 3, I'm gonna get 0 or something extremely close to 0. Maybe this number is just an approximation, but it's gonna be a very good approximation. Okay, try to do this at home with the calculator, and you should be getting that all of this is in fact equal to 0. So that's how you solve. You can solve the equations, guys, by having a graphing calculator. What you do is basically, I'm gonna erase everything and give you another example. Let's suppose you have 2x squared plus x to the 4 equals 2x. Okay, what you're gonna do is bring everything to one side of the equation. So you're gonna have, well, let me write everything in descending order of powers. We're gonna have x to the 4, and then we're gonna have plus 2x squared, and then minus x equals 0. Okay, this equation may be difficult to solve analytically, so don't do it. Just create a function out of this expression, like so. Find the roots or the zeros of this function by a with a graphical calculator. Let's do it. X squared plus 2x, x to the 4 plus 2x squared minus x. X to the 4 plus 2x squared minus x. And as you can see, we have the function, the graph of the function. We can see the zeros. Let's zoom in. In this case, they are very close to the x-axis, so we have to zoom in. And the zeros are 0 and 0.4534. Okay, so these two numbers, 0 and 0.4534, are the roots of this function, and therefore by default they are gonna be the roots. I'm sorry, they're gonna be the solutions to my original equation, which is this. Okay, so that's how you can solve an equation, guys, by using a graphic calculator, by first going through its, let's call it its associated function. Okay, that's how you can do it. Okay, guys, so that's it. That's how you do this. It's very simple. I'm not gonna continue with the process. There's no need to, and you can go straight to the exercises. So thank you, guys.